Thank you. Students, the subject is network theory for electrical circuits. This is one of the important subject for any computer exams point of view, mainly for GATE and ESC point or any other PSUs also. Can expect more weightage from the network theory, and it is an easily scoring subject also. Before starting the actual syllabus, first let me introduce myself. My name is Surendra Babu. I have 12 plus years of experience in GATE, ESC and PSUs. These are the subjects I am teaching for various computer exams. For GATE EEE, this electrical circuit syllabus, the electrical circuits and network elements. These are the concepts that they given in GATE syllabus. Ideal voltage and current sources, dependent sources, RLC elements, network solution method, that is KCL, KVL, nodal and mesh analysis. I think all of you, EEE students, you know this syllabus. Network theorems. In theorems, mainly Norton's, Thevenin's, Norton's, superposition and maximum power transfer theorem it is given, the syllabus. Yes. Transient response of DC and AC networks. Sinusoidal steady state analysis, resonance, two-port networks, balanced three-phase circuits, star-delta transformation, complex power and power factor in AC circuits. This is the GATE syllabus for electrical students, that is from electrical circuits. For EC students, you know the syllabus. Maximum for electrical and EC, nearly the syllabus is same. But for EEE students, extra topic is three-phase circuits. But for EC students, the three-phase circuits is not there. Nodal and mesh analysis, superposition, Thevenin's theorem, Norton's theorem, reciprocity, sinusoidal steady state analysis, phasors, complex power, maximum power transfer, time and frequency domain analysis of linear circuits, RLC, RC and RLC circuits, solutions of network equations using Laplace transform, linear two-port network parameters, star-delta transformation. This is for EC students. This is the ESC syllabus for electricals. You please go through this one. This is the ESC syllabus for electronics, that is electronics and telecommunication engineering, ENT. This is the ESC syllabus. According to given syllabus for both, by considering GATE and ESC syllabus, I divide into different chapters. This is the sequence I am following. The total network theory course or network theory concepts. This sequence only I am going to explain. First, I will start with some introduction. Then after discussing the introduction, then I will discuss the fundamentals of electrical circuits. After completing the fundamentals, then sinusoidal steady state analysis. In sinusoidal steady state analysis, mainly I have to discuss AC analysis. And the concept of resonance. One is AC analysis. The next one is resonance concept. The next one is coupled circuits. That is the magnetic circuits, coupled circuits. These topics will be covered in the sinusoidal steady state analysis. That is AC analysis, resonance, coupled circuits. Then after completing this AC analysis, resonance and coupled circuits, then I will start the network theorems. The fourth chapter is transient. Students, this I divided into different chapters according to given GATE and ESC syllabus. By considering the GATE and ESC syllabus, different chapters. And in this DC transient analysis, then I have to discuss AC transient analysis. In this, the response of RL circuit, RC circuit, RLC circuit will be covered. In this, DC transient analysis, AC transient analysis. The next one is two-port networks, three-phase circuits, graph theory, and filter circuits. This is the sequence that I'm going to explain various concepts with respect to network theory. Then first we'll start with some introduction. Before starting that, this is the weightage, expected weightage for EC GATE point of. This approximately this 8 marks it is given, but expected weightage is, we can expect average is 8 marks, but it is not a fixed weightage, plus or minus 1 mark, students. 7 to 9 marks, up to 10 marks also we can expect. This is the expected weightage, 7 to 9 marks for GATE EC students. For GATE EEE, we can expect 8 to 10 marks also. 8 to 10 marks we can expect for EEE. This expected weightage from electrical circuits. Various subjects also I given. Actually, this weightage I taken GATE 2023. I think this is GATE 2023 weightage. You see the 2024 weightage also nearly approximately 8 to 10 marks only. 2023 it is asked 7 marks. This subject-wise ESC weightage, please go through this one. Just I taken this slide because we get some idea what is the weightage is asking in GATE exam and ESC exam, various subjects. For that reason only I selected this slides. You please go through this one. I will share this PPT. Please go through this. And this is triple ESC weightage for various subjects. That you please go through this. See these are the number of questions. In ESC point of view, it is not a marks. It is a number of questions. In ESC, each question is 2 marks. If you take the network theory, that is network electrical circuits, this 10 into 2, 20 marks for objective point. For EC students, the networks have to take given different years here. But some 1 year, I think it is 2021, 2022, 2023. Okay, 15 into 2, 12 into 2, 14 into 2. It's 3 years. 2021, 2022, 2023 students. This is the expected weightage. Then what are the reference books? So many books are there, but mainly you have to concentrate these 3 books, students. One is Engineering Circuit Analysis by Heath and Kimmerly. Network Analysis by Van Valkenburg. Fundamentals of Electrical Circuits by Alexander and Sadiq. And so many other books also there. For more number of questions, you have to practice that is Electrical Circuits by Chakravarti. That book also there. But my point of view, mainly you have to concentrate these 2 books. And in Network Analysis by Van Valkenburg, for every chapter ending, there is unsolved questions are there. That questions also you have to practice. But in Alexander and Sadiq, there is a more number of practice questions are there. You have to practice that. There is some solved questions are there and unsolved questions also there. You practice that question. Maximum directly that questions only asking in GATE. That models are that questions directly also it is asking. These are the reference books that you have to concentrate. Then first we'll start with some introduction. Students, we know that according to band theory of solids, the solids are classified into conductors, insulators, semiconductors. This conductors is also called metals. This minimum knowledge that I am going giving before entering to the actual concept. According to band theory of solids, the solids are conductors, insulators, and semiconductors. When the particular solids are said to be conductors, we know that in some materials, the outer electrons of each atom or molecules only weakly bounded. That is, the outermost electrons are weakly bounded to the atom or molecule. These electrons are almost free to move throughout the body of the material. These electrons are freely moving throughout the body of the material. And those electrons are called which electrons, students? Free electrons. I think all of you know these points. This is minimum physics concept. Before entering to the concept, minimum knowledge. These electrons are freely moving throughout the body of the atoms or molecule. These are called free electrons. This free electrons is also known as conduction electrons, students. The free electrons is also called conduction electrons. We know that if these conductors are placed in an electric field, the electrons are moving in a direction opposite to electric field. Why it is moving opposite to electric field? Later I will explain. Whenever these conductors are placed in an electric field, there is a force is produced on each electron. Because of that force, the electrons are moving in the direction opposite to electric field. If the in any solid, if the electrons are moving, in any material, if the electrons are moving, those are called conductors. Such materials are called conductors. That is, the materials which having the freely moving electrons, the materials which having the conduction electrons, those materials are called conductors. Then, what is the examples of conductors? Silver is the conductor. Gold also conductor. Copper is also conductor. Aluminium, mercury, steel, iron, seawater, platinum, brass, bronze, graphite, dirty water, lemon juice, etc. All these are the conductors. That means conductors are having the free electrons or conduction electrons. Those electrons are always moving opposite to electric field. Why these are moving opposite to electric field? Later we'll see. I think all of you well known what is the valency band, what is the conduction band. This minimum physics concept, please go through this one. What is the valence band and what is the conduction band? The electrons in the outermost shell are known as valence electrons. These electrons consist of series of energy levels and forms the energy band. That band is called valence band. The valence band is the highest occupied energy level. What is the conduction band? The valence electrons are not tightly held to the nucleus, due to which a few of these valence electrons leave the outermost orbit, even at room temperature, and becomes free electrons. That means conduction band consists of free electrons. The free electrons conduct the current in the conductors and therefore known as conduction electrons. The conduction band that contains conduction electrons and has the lowest occupied energy. This is what this minimum knowledge in physics, that valence band and conduction. What are the per gap source? What is the per energy gap? We know that the gap between the valency band and conduction band referred to as per gap. This is the gap between conduction band and valency band. This is called band gap or per energy gap. The per gap does not have any energy and no electrons stay in this band. There is no movement of electrons in this band. If the per energy gap is greater, the valence band electrons are tightly bounded, attached to the nucleus. That means there is no free electrons. In such case, we require some amount of energy for the movement of the electron. That energy is equal to the per energy gap energy. Students, we know that in insulators, what is the band gap energy? In insulators, what is the band gap energy? In insulator, the band gap energy is greater than or equal to 5 electron volt. There is a large band gap. This is the semiconductors. In semiconductors, the band gap energy is very small. It is nearly equal to, I think all of you well know this, 1 electron volt. But in the case of conductors or metals, the valency band and conduction band is overlap. Valence band and conduction band is overlap because of free movement of electrons. Then what is the band gap energy? 0 electron volt. That means in the case of insulator, there is a large band gap. In semiconductor, there is a small band gap energy. But in the case of conductors, the valency band and conduction band is overlap. Then there is a free movement of electrons. I think we know this. In semiconductors, just a minute, sir. In semiconductors, please listen this concept. Let this is the conduction band, and this is the valency band. Take the example of semiconductors. In semiconductors, this is the conduction band, this is the valency band. If you apply the external energy, in valency band there is a free electrons. In valency band there is a free electrons. In valency band there is a free electrons. If you take semiconductor, if external energy is applied, what happens, friends? If external energy is applied, if this is breakdown, some of the electrons are moving from valency band to conduction band. Valency band to conduction band. If the electrons are moving from valency band to conduction band, whenever this energy gap, if you apply the voltage, if external energy is applied, if the applied energy is greater than 1 electron volt, then there is a movement of electrons from valency band to conduction band. The absence of electron in valency band is called hole, because there is some band gap. If this is breakdown, there is a movement of electrons from valency band to conduction band. The absence of electron in valency band is called hole. That's the reason why in semiconductors the conductivity is due to both holes and electrons. Both holes and electrons. That's why there is a concept of hole in semiconductors, because initially the conduction band and valency band is not overlap. If you apply external energy, then only the electrons are moving from valency band to conduction band, and there is absence of electron in valency band. Then that absence of electron in valency band is nothing but hole. Hence, there is a conductivity is due to both holes and electrons. Students, but you know that in case of conductors, just a minute, I'm adding the slide. That is, in semiconductor, students, in semiconductors, let us assume that external energy is temperature. If temperature is increases, the number of electrons in conduction band is increases. Number of electrons in conduction band is increases. Then what the conductivity increases. What is the resistivity decreases. What the resistance? That is, in semiconductors, if temperature is increases, what about the resistance, friends? That's the reason why it is having positive temperature coefficient or negative temperature coefficient. It's having the negative temperature coefficient. That's why semiconductors are having the negative temperature coefficient. That is, if you draw the characteristics between resistance versus temperature, if temperature is increases, what about the resistance? Resistance is decreases. Temperature is increases, resistance is it is having negative temperature. But what about in conductors? In conductors are metals. Already the valency band and conduction band is overlap. This is conduction band and this is valency band. This is overlap. Overlap means within the conductor, the electrons are freely moving. Already the electrons are freely moving. If you apply any external energy, let external energy is temperature. If you apply any external energy, let the external energy is temperature. If temperature is increases, the electrons are accelerated. Because of acceleration of the electrons, there is a collision takes place. Because of collision of the electrons, the drift velocity is reduced. When the drift velocity is reduced, what about the conductivity reduces? Because of collision of electrons, if temperature is increases, because already electrons are freely moving now. If you apply any external energy, because of that energy, due to collision of electrons, then the conductivity is reduces, resistivity increases, resistance is increases. That is, in conductors, if temperature is increases, what about the resistance, friends? Increases. That's the reason why conductors are metals. There is a positive temperature coefficient. And one more point you have to remember here, friends. In the case of semiconductors, there is a concept of electron and hole because absence of electron. But here, already electrons are freely moving. There is no concept of absence of electron here. That's why throughout study of electric circuits, there is no concept of hole. Why? Already electrons are freely moving. Throughout study of electric circuits, we are studying the conductors only. Throughout study of electric circuits, electric circuits are studying based on the conductors. There is a concept of only electron. There is no concept of hole. At that point, the conductors, the conductivity is due to only electrons. In semiconductors, the conductivity is due to which ones, friends? In semiconductors, the conductivity is due to both holes and electrons. Sir, what about insulators? That concept is different. In insulators, there is a concept of displacement current. There is a current of displacement current, that is because of the dipole moment. Because of dipole moment, there is a current. But all this is not required. But you know, this is the minimum knowledge. Semiconductors are having negative temperature coefficient and conductors having the positive temperature coefficient. If you draw the characteristics between resistance versus temperature, if the temperature is increases, what about the resistance? Increases. If the temperature is increases, the resistance also increases. We can get the characteristics like this. It is a linear characteristics. And this is the non-linear characteristics. So non-linear. Clear? Any doubt? This is the minimum introduction. Any doubts, friends? Please respond. Yes. If you don't have any doubts, then we'll start with the first chapter, that is fundamentals of electrical circuits. Uh, before this, I'm giving one homework for you. Practice. Practice. This is for homework. Try this one, students. Write the differences between. Write the differences between. Please try to practice this one. Differences between insulators, semiconductors, and conductors. Try to know this one, students. Conductors. What type of current is exist? What type of bonding is exist? Is it a covalent bond? Is it ionic bonding? Is it metal bonding? Current is due to only electrons or both holes and electrons. What type of current is exist? Okay. What is the temperature coefficient? All this minimum try to practice this one. You have to know the what is the differences between insulators, conductors, and semiconductors. Try to know that. The chapter 1 is fundamentals of electric circuits. In this, the first concept is basic quantities that I have to discuss. Have some minimum knowledge on what is the charge, what is the current, what is current density, drift speed, mobility, what is electric field, what is potential, what is the potential difference, what is the work done, what is energy, what is the power. These are the basic quantities. This is the first concept in fundamentals of electric circuits. First, we'll start with what is electric charge. We know that the electric charge is an electric property of the atomic particles of which matter consists. This is one of the electric property of the any atomic particle. The charge is measured in coulombs. What is the units of electric charge? That it is measured in coulombs. That is the units. The units of charge is coulomb. Units of charge is measured in coulombs. The charge of a proton is 1.602. Exact value is 1.602 into 10 to the power of minus 19. Proton charge is positive. The charge of electron is minus 1.602 into 10 to the power of minus 19 coulombs. The electron charge is negative. 1 coulomb is the net charge is 6.24 into 10 to the power of 18 electrons. 1 coulomb of the charge consists of how many electrons? 6.24 into 10 to the power of 18 electrons it consists. This is charge on 1 electron. The charge of 1 electron. Charge on 1 electron source. 1 coulomb of charge is 6.24 into 10 to the power of 18 electrons. If number of electrons equal to number of protons, if number of electrons equal to number of protons, what is the net charge, friends? If number of electrons equal number of protons, the net charge equal to 0. Net charge equal to 0. If any atom loses the electrons, if any atom loses the electrons, which is more dominant? Positive charge is dominant or negative charge is dominant? Positive charge is dominant. It lost in the electron, positive charge is dominant. That is Q net greater than 0. If any atom gains the electrons, if any atom gains the electrons, which is dominant? Positive charge is dominant or negative charge is dominant? Negative charge is dominant. Negative charge is dominant. If it is gaining the electrons, means more number of electrons, means the net charge becomes negative, Q net less than 0. If it is losing the electrons, Q net positive, that is greater than 0. If it is gaining the electrons, Q net less than 0, negative charge is the more dominant. Negative charge is the more. This is about electric charge. Electric charge is that is the property of atomic particles which matter consists. The charge is measured. You have to represent electric charge either Q. You have to use either small q or capital Q. Then before defining the what is the definition of electric current, I have to explain what is the mechanism of electric current through the conductors. Let's consider any conductor. Let's consider a conductor. Consider a conductor. Students, you know that there is so many types of conductors are there. You know what are the different types of conductor? Silver is the conductor. Even gold is also conductor. Aluminum is also conductor. Copper is also conductor. So the different types of conductors. Among all these conductors, which is the highest to conductivity, students? The silver is highest to conductivity. Silver is the highest to conductivity. Why the silver is the highest to conductivity? The mobility of electrons in silver. The mobility of electrons in silver. Electrons in silver several times greater than other conductors. Greater than other conductors. Because of this reason, silver is having highest to conductivity. We know that every conductor is very rich in electrons. Every conductor is very rich in electrons. Very rich in electrons. It is having 10 to the power of 18 to 10 to the power of 23 electrons per volume, per unit volume. Electrons per unit volume. These are the number of electrons. Most of the conductors, it is having in the range of 10 to the power of 18 to 10 to the power of 23 electrons per unit volume. That's why every conductor is very rich in electrons. Let L is the length of the conductor. Let L equal to length of the conductor. Length of the conductor. Very important formulas we have to derive it. That is very important. A is the cross-sectional area of the conductor. Cross-sectional area of the conductor. This is the conductor. This is the conductor. The length of the conductor is L. The area, cross-sectional area of the conductor is. If this conductor is placed in any electric field, let E equal to electric field. Let E equal to electric field. If the conductor is placed in electric field, the conductor is placed in electric field. What exact electric field? Later I will explain. Placed in electric field. There exists force on each electron. There exists force on each electron. Force on each electron. Force on each electron. Then what is the force applied on each electron? The force produced on each electron, F equal to minus E into E. The force produced on each electron is minus E into E. That is, the force is opposite to electric field. If this is the electric field direction, let this is the electric field direction. This is the electric field direction. The electric field direction is like this. Then why this negative sign? Because electron is having a negative charge. The force is this direction. That is, force is opposite to electric field. Force is opposite to electric field. Because of this negative charge, electric field. Because of this force, the electrons are moving. Due to this force, the electrons are moving. The electrons are moving in the direction of force. In the direction of force. In the direction of force. Because of the force, only electrons are moving. The electrons are moving in the direction of force. If the electrons are moving in the direction of force, means we know this. This is the field direction. This is the force direction. Then electrons are moving in the direction of the force. Let the net charge is moving. Q equal to Ne. How much net charge is moving? Let for n number of electrons, each electron charge is E. The net charge is, this is the net charge per unit volume. Q equal to Ne. That's why this is the direction of the electron. Starting I told students, the electrons are moving opposite to electric field. Electrons are moving opposite to electric field. This is the reason. The force equal to minus E into E. This negative sign because electrons are having negative charge. That is force is opposite to electric field. Always electrons are moving in the direction of force only. Then electrons are moving opposite to electric field. That is each electron charge is letter. Each electron charge is E students. Each electron charge equal to E. For n number of electrons, very important, for n number of electrons, what is the net charge? Net charge Q equal to Ne. Due to this force, this much of charge is moving in the conductor. Due to this force, this much of charge is moving in the conductor. Due to force, this charge is moving opposite to electric field. That means whenever the conductor is placed in electric field, there is a force is produced. Because of the force, the electrons are moving like this. The electrons are moving opposite to electric field. Now with this knowledge, I have to define what is the current. The electric current is defined as the rate of flow of charge of the conductor. It is defined as the rate of flow of charge of the conductor. The rate of flow of charge of the conductor is called, actually, current we are giving, the electric current is we are giving as a definition. But in the conductor which is moving, charge is moving. That rate of charge is nothing but a current. The continuous flow of electrons in an electric circuit is called electric current. This is a continuous flow of electrons in electric circuit is called electric current. This is the electric field direction. This is electric field direction. And this is the direction of the force. Force is applied this direction. Field is applied this direction. Then these electrons are moving in the direction of force. This is the electrons are moving. These electrons are moving. Okay, this is the movement of the electrons. These are electrons, not the current directions are. It is electron direction. These are which one? Electrons are moving like this. Electron direction. See that how the electrons are moving. Opposite to electric field it is moving. In the direction of force it is moving. What is the net charge for n number of electrons? The net charge equal to n. Now with this, now I am defining the current. The rate of flow of charge of the electric current is defined as the rate of flow of charge of the conductor. Therefore, current I equal to dq by dt. This one formula. dq by dt. This, or you can also write I equal to q by t. You can write q by t. Q is ne by t, where n is the number of electrons, E is the electron charge. I equal to q by t, that equal to ne by t. Then from this, once you know the current, how to find the charge? From this, q equal to integral I dt. If you integrate the current, we can get the charge. Integration is nothing but area squares. That is area under the current curve. Area under current curve. Area under current curve indicates which one? Area under current curve indicates charge. If any current curve is given, if you calculate the area under the curve, that gives the charge. Area under current curve indicates the charge. We can also write from this one, q equal to IT squares. Charge equal to current into charge equal to current. Then you know what is the units of current? Units, that is coulomb per second or ampere. Coulomb per second or amperes. That's the units of current. But one observation here, sir. Here I given I equal to dq by dt. I equal to dq by dt I given. Correct? dq by dt. Shall I write like this? Q by t. Q equal to Ne. But what is the electron charge? Electron charge is negative. Electron charge is negative. Electron charge is negative. If electron charge is negative, we have to take negative here. What this negative sign indicates? The current direction, conventional current direction is opposite to electron direction. Therefore, conventional current direction is opposite to electron direction because of the negative sign. Opposite to electron direction. electron direction. If conventional current direction is opposite to electron direction, now electrons are moving this direction, electrons are moving like this, then you have to take current direction is like this. This is the current direction. Opposite to this, you have to take this is the current direction. This is the current direction. That means in general, the current direction is taken as positive to negative. This is the current direction, positive plate to negative. That is, current direction is in the direction of electric field or opposite electric field, sir. The current direction is in the direction of electric field or opposite electric field. In the direction of electric field. Electron direction is opposite electric. I equal dq by dt, that is q by t, q equal to ne, but electron is having negative charge, that's why taken minus. Then this negative sign indicates the current direction is opposite to electron direction. This is what the definition of the electric current. Then once you know the current, how to find the charge? Area under the current curve gives the charge. The next one is, up to now I explained what is the charge, what is the charge, what is the current. These are the minimum basic quantity, students. Minimum knowledge. What is the electric? The next one is, what is the current density? What is the current density? We know that the amount of electric current traveling per unit cross-sectional area, how much amount of current is traveling, that is called current density. Then what is the current density? J equals, friends, I by A. The current density J equal to I by A. We know this. What about the current and electric field? Electric field and current is same direction or opposite direction? Same direction. Electric field and current is same direction. If the electric field and current is same direction, what is the current density? Current density is also same direction. That is, electric field, current and current density. Why taken same direction, friends? That I told already. Current is in the direction of electric field. Opposite to force, na? Opposite to force means same direction of electric field. Electric field, current and current density is in the same direction. What are the units of current density, friends? Can anybody? What are the units? The units of current density is ampere per meter square. Ampere per, where J is the current density, that is ampere per meter square is the units of current density. Now, very important observations, friends, that you have to concentrate. Now I'm asking one question. If electric field is increases, if you apply the more electric field, if electric field E is increases, what is the force on each electron? If electric field is increases, friends, the force on each electron is increases. If the force on each electron is increases, the force produced on each electron is increases, what is the net charge traveling? Q is increases. If Q is increases, friends, what about I? I is increases. If current is increases, what about the current density? That is, what is the observation here? If electric field is increases, the current density is also increases. Then what is the relation between electric field and current density? That is, J is proportional to E, sir. If you remove the proportionality, we can get some constant, that is the sigma. J equal to sigma E. Very, very important relation. If electric field is increases, current density is increases, we are getting J equal to sigma E. This is called first form of Ohm's law. This is called first form of Ohm's law. Ohm's law. Mainly, this formula is applied in the magnetic field theory. It is applied in magnetic field theory. That you know in EMF subject, it is applied in magnetic field theory. Magnetic field theory. J equal to sigma E. But this formula is applicable at temperature is constant and conductivity is constant. What is the sigma here? Where sigma is the conductivity space. What is sigma here? Sigma equal to conductivity. This form J equal to sigma E. J equal to sigma E. It is applied at for a given conductor, conductivity is constant and temperature is also constant. Then only this formula is applicable at constant temperature and constant conductivity. At constant temperature and constant conductivity, then what is sigma equal to J by E? Sigma equal to J by E. Then if you draw the characteristics, friends, if you draw the characteristics between J versus E, this we can get the characteristics. In J versus E characteristics, if any characteristics are given J versus E, the slope of this curve gives which one? Y-axis coordinate by x-axis coordinate, J by E. What is J by E? Conductivity. If the characteristics are given between J versus E, what the slope of the curve indicates, if the question is asked, the slope of that curve indicates the conductivity. That is about what exactly? Current and current density. And what is the first form of Ohm's law? The first form of Ohm's law equal to J equal to sigma E. Mainly this formula is used in magnetic field theory. Then one more important definition, drift speed. Students, I told already, in conductors, the electrons are freely moving. In conductors, the electrons are freely moving. If any external energy is applied, there is a collision between the electrons. It is having some speed. How to define drift speed? The average speed with which electron drift in the direction opposite to electric field. The average speed in which electron drift in the direction opposite to electric field. That is called a drift speed. Let us assume this is the actual path of the electron. This is the actual path of the electron. We take like this. This is the actual path of the electron. Because of electric field is applied, there is a drift in the speed, average speed with which electron will drift. Then there is a drift in the speed of the electron after electric field is applied. What is this average speed? That you have to calculate. That speed is nothing but a drift speed. Now, how to calculate the speed? Students, what is the force on each electron? Whenever force is applied, I am taking the only magnitude, I am not considering the any side. What is the force on each electron? F equal to E. Take the magnitude. But you know that force equal to ma. Because electron is having some mass, then the electron is accelerated due to electric field. Friends, electric field, the electron is accelerated. Then let us assume that the acceleration of the electron is a, then force equal to ma, then ma equal to E into E. From this, what is a equal to? E by m squares. Important formulas, please concentrate. E by m. What is m here, friends? Mass of electron. Can anybody tell what is the mass of electron? 9.109 into 10 to the power of minus 31 kg. Or 9.109 into 10 to the power of minus 28 grams. This is the mass of electron. Okay, this is acceleration of the electron. Because of this, due to electric field, the electron is accelerated. What is the acceleration in the electron? The acceleration in the electron equal to E by m. But let's assume that the average time between the two successive collisions, the average time, one electron is collision with another electrons, and this electron is collision with another electron. The average time between two successive collisions is tau. That is called relaxation time. Let the relaxation time is tau. It is average time between the two successive collisions. That is called relaxation time. Once you know the time, how to find the velocity? Acceleration equal to velocity by time. Velocity by time. From this, what is the velocity, friends? Velocity equal to acceleration into time. Like that, I have to find drift velocity. The drift velocity equal to, or drift speed. Drift velocity or drift speed equal to. How to find drift speed, friends? Acceleration into time. The drift speed equal to acceleration into time. A time is the relaxation time. That is the time taken for two successive collisions. What is acceleration? E by m into tau. This is called drift speed or drift velocity. That is v. Okay, this is also very important. The drift speed or drift velocity equal to E by m into tau, where tau is the relaxation time. Now, how to find what is the current in terms of the drift speed? What is the current expression? Very important. Current in terms of drift speed. In terms of drift speed. How to find the current in terms of the drift speed? Let's concentrate. We know that this is the conductor. This is the conductor. Let the length of the conductor is L. L is the length of the conductor. Length of the conductor. The time taken for the charge to cross the conductor. How much time is traveling the charge within the conductor? Because of electric field, the charge is moving. where dt is the time taken for the movement of the charge in the conductor. Then how to define velocity, friends? Velocity or drift velocity. The drift velocity equal to fundamental definition. The drift velocity equal to the total distance by time. Velocity equal distance by time. What is the distance here? Length of the conductor is distance. Let the time taken is dt. Then what the total length equal to Vd into dt. I'm writing the formula in terms of drift speed. Current formula in terms of drift speed. Okay. Then you have to calculate what is the volume of the conductor, friends. Volume of conductor. The volume of the conductor equal to area into length. Area of the conductor into length of the conductor. The total charge in volume of the conductor. Total charge in volume of the conductor. Volume of the conductor. In total volume of the conductor, how much charge is present? The total charge in the volume of the conductor is per unit volume Ne charge. Per unit volume Ne charge into 1. That gives the total charge in the volume. That is in the total volume of the conductor, how much charge is present into 1. The total charge in the volume of the conductor is Ne into 1. I told already, friends. Q equal to Ne. Na? This Q equal to Ne. This is per unit volume. This Q equal to Ne is, the charge is per unit volume of the conductor. Just a minute. Q equal to Ne. This is per unit volume of the conductor. But now I'm asking for total volume, V volume. For the total volume, how much charge is present? Into V, into volume of the conductor. Then dq equal to Ne into, what is the volume of the conductor? A into L. Then dq equal to Ne into A. But what is L in terms of drift velocity? Vd into dt. Vd into dt. Can you bring this dt this side? dq by dt. dq by dt. dq by dt equal to N into E into A into Vd. What is the dq by dt? Current. This is the current in terms of drift speed. Current in terms of drift speed. NEA into Vd. Very important formulas that you have to. Where Vd is the drift velocity or drift speed, then NEA into Vd. That's the current expression. We can also write like this. This is one formula. I equal to NEA into, what is the drift speed formula, friends? Different ways of writing. E by M into tau. M into tau. That is NE square AE tau by M. See, different formulas I'm writing. This is the current expression in terms of electric field, relaxation time, and mass of the electron. NE square AE tau by M. Yeah, this is also important for this also. Yeah, this is about the current in terms of drift velocity. Up to now I explained what is the charge, what is the current, what is the current density, what is the first form of Ohm's law, what is the expression for current in terms of drift velocity or drift speed, and what is the drift speed. Next, have to concentrate what is the mobility of electrons. Mobility of electrons. This also. Before giving the definition of the mobility of electrons, students, we know that if electric field is increases, see this one. What is the drift speed? E by M into tau. If electric field is increases, what is the drift velocity? Increases. The drift velocity is increases. Then what is the relation between drift velocity, drift speed and electric field? Vd is proportional to E. If you remove the proportionality, some constant mu into E, where mu equal to Vd by E. This is called which one, friends? Mobility of electrons. Mobility of electrons. Then what is the definition of mobility of electrons? Very important. What is the definition of mobility of electrons? The magnitude of drift velocity or drift speed per unit electric field. The magnitude of drift speed per unit electric field. Per unit electric field. per unit electric field is called mobility of electrons. It's called mobility of electrons. Is called mobility of electrons. The magnitude of drift to speed per unit electric field is called mobility of electrons. What is the units of mobility of electrons? Can anybody? What is the units of mobility of electrons? Units. Drift to speed, na? Drift to speed. This is the drift to speed units. Speed units, meter per second. That is meter per second. Electric field units. This electric field units. Electric field units. Volts per meter. This is in volts per meter. Then meter square per volt per second. This is the units of mobility. Units of mobility. The units of mobility is meter square per volt per second. Volt per second. So volt per second. Okay, this is the mobility. We can also write mobility formula, the another form of mobility formula, mu equal to Vd by E. No? What is Vd formula? E by m into tau squares by E. E cancel. E tau by m. This is one more form. E tau by m. What is small e here? Electron charge. Small e is the electron charge. Capital E is the electric field. This is another formula for mobility. One formula for mobility is Vd by E. The another formula in terms of electron charge, E tau by. Yes, please. One more point to remember that I told already. There is a collision of electrons are freely moving. When the electrons are accelerated, there is a collision of electrons. Because of collision of electrons, there is a loss of energy. Because of collision of electrons, there is a loss of energy. This loss of energy is in terms of kinetic energy. Why? Why it is a kinetic energy? Because of movement of the electrons, during movement of electrons, there is a loss of energy. That loss of energy is which loss of kinetic energy? Then how to calculate what is that kinetic energy? This I am writing. Due to collision of electrons, due to collision of electrons, there is a loss of energy. Why there is a collision of electrons? Once electrons are accelerated, because already it is freely moving. Once it is accelerated, there is a collision. There is a loss of energy. There is a loss of energy. This loss of energy is in the form of kinetic energy. This loss of energy is kinetic energy. Energy is kinetic energy. How much kinetic energy is lost? Then how to write kinetic energy, students? The kinetic energy equal to, how to write? The kinetic energy equal to half mv square. No? But here velocity is the drift velocity. Half m into vd square. Then you have to substitute the kinetic energy equal to half m into what is the drift velocity? E by m into tau whole square. If you simplify this, we can get a half m into e square tau square by m square. This m cancel. Then what is the kinetic energy? E square tau square by e square tau square by 2m squares. This is the kinetic energy. This much of energy losses takes place due to collision of electrons. E square m square e square tau square by 2. But you know that this is the loss of energy. This energy loss is dissipated in the form of heat. This loss of energy is dissipated in the form of heat. That loss is taken as a power loss. That loss is taken as a power loss. This loss of energy in the conductor, what is the reason for power loss? This is the reason. This loss of energy in the form of heat, this loss of energy is in the form of heat, and this is taken as a power loss. What is the power loss? Then one of the formula for power loss equal to J into E squares. J into E. Then what is J? Sigma E into E. The power loss equal to sigma E. Sigma. we can get power loss equal to I square R, power loss equal to V square by R in terms of resistor. Later on we'll see how we can get that formula also. But generally, this is one formula for power loss. Sigma into E square. What are the units of this one? This is power loss per unit volume. This is power loss per unit volume. Per unit volume. Per unit volume. What are the units of J? Ampere per meter square. What are the units of E? Volt per meter. Volt per meter. Current into voltage. Watt. Current into voltage friends. This is ampere per meter na. This is volt per meter na. This is ampere per meter square. Sir. This is volt per meter na. Ampere into voltage. Watt. Watt per meter cube. That's why I told per unit watt. Watt per meter. This is in terms of watt per meter. This is happening. Power loss is happening because of which one, friends? Power loss is happening because of which one? Collision of electrons. Why the collision of electrons? Because of acceleration of the electrons. Why the acceleration of electrons? Because of electric field. Understand? If electric field is applied, electron is accelerated, collision is takes place. Collision is takes place. Because of the collision, there exists power loss. There exists power loss. If electric field is zero, we are not applying any field. That is, the conductor is not placed in any electric field. If electric field is zero, what the mobility of electron? Mobility of electron is zero. If the mobility of electron is zero, what the drift speed? Zero. If the drift speed is zero, what the kinetic energy? Kinetic energy equal to zero. If the kinetic energy is zero, what the power loss? Power loss is zero. That's the reason why in any conductor, there is no electric field, there is no current, there is no power loss. Whenever if you apply the voltage or electric field is applied, sir, this is the conductor. Simply if you leave the conductor like this, no power loss, no movement of electrons. When I connect the supply, voltage is applied. Because of voltage, there is electric field. Because of electric field, there is a movement of electrons. Once the movement of electrons is present, there is a mobility of electrons, there is a drift velocity, there is a kinetic energy. Then power loss is not equal to zero. But here what I am telling, if you don't apply any field, no movement of electrons, mobility is zero, drift velocity is zero, kinetic energy zero, there is no power loss. Power loss takes place if there is a movement of charge, if there is a movement of electrons, if the electrons are accelerated, I'm talking about accelerated, then only collision. If there is a collision, then only there is a power loss. So there is no electric field, there is no any power loss. This about what exactly? Charge and current. Charge and current. In the basic parameters, in the basic quantities, friends, the topic I started, chapter 1 is which one? Basics of electrical circuits. In this basics of electrical circuits, charge, current, current density, drift speed, mobility is complete. Then before starting the electric field potential difference, we have to see how the questions will ask based on the current and charge. Can anybody answer this one? The total charge entering a terminal is given by Q equal to 5t sine 4 pi t millicoulombs. Calculate the current at t equal to 0.5 seconds. Can you try it? Come on, do it. Just a minute, please do this. Students, what is the answer? You have to find the current at t equal to 0.5 seconds. You know that I equal to dq by dt squares. Then d by dt of what is q? 5t sine 4 pi t. It's a millicoulombs, 10 to the power of minus 3. This is UV rule, differentiation. This is 5 into 10 power minus 3, taking this common. T is constant, d by dt of sine 4 pi t. Plus sine 4 pi t is constant, d by dt of t. That is 5 into 10 power minus 3, t into cos 4 pi t into 4 pi. It's correct. Again, if you differentiate this 4 pi. Sine 4 pi t, constant t differentiation 1. Then 5 into 10 power minus 3, 4 pi t into cos 4 pi t plus sine 4 pi t squares. Substitute t equal to 0.5. How to find the current at t equal to 0.5? At t equal to 0.5. Then what are the current, students? 5 into 10 power minus 3. You substitute t equals 0.5. 4 pi into 0.5. Cos 4 pi t is 0.5. This is in radians. You multiply with 180 by pi. You convert into degree. Multiply 180 by pi. You convert into degree, students. Correct? Or otherwise, you directly write pi equal to 180 degrees. Instead of 180 by pi, you have to write pi equal to 180 degrees. Better to write like this. 4 pi into 0.5 plus sine 4 pi into 0.5. T equal to 0.5 second. That is 5 into 10 power minus 3. This is how much? 0.5 into 4 pi. I substituted 2 times here. Correct? 0.5, 4 pi t. That is 0.5 into, I'm writing. This 4 pi into 0.5. Okay. Then 4 pi into 0.5. This is 2 pi. This is 2 pi into cos. How much that? Cos 2 pi na? Cos 2 pi. Cos 2 pi. This is 0. This is sin 2 pi. Sin 360 0. 5 into 10 power minus 3. 2 pi into. That is cos 360 is 1. This is cos 360, sir. 1. Then final answer is how much? Final answer. I equal to 10 pi into 10 power minus 3. Pi is 3.14 now. 31.4 milliamps. This is the final answer. All of you got? 31.4 million. Just make the differentiation, substitute t equal to 0.5 seconds. We are getting 31.4 milliamps. Clear? This is 2 pi. You substitute in degrees. 2 pi is 360 degrees. This I taken 2 pi equal to 360 degrees. Then sin 360 is 0. Cos 361. 1 into 2 pi, 2 pi. 2 pi into 5, 10 pi. 10 pi into 10, that is 31.4 milliamps. Next. Determine the total charge entering a terminal between t equal to 1 second, t equal to 2 seconds. If the current I equal to 3t square minus t amperes. You have to find the charge. Once you know the current, how to find the charge? Q equal to integral I dt. This integral 1 to 2. 3t square minus t. dt. Then what is the Q equal to? Integral 1 to 2. 3t square dt minus integral 1 to 2 t dt. What is the integration of t square? T cube by 3. What are the limits? 1 to 2. What is the integration of t? T square by 2. What are the limits? 1 to 2. 3 3 cancel. 2 cube minus 1 cube. This 3 cancel. 2 square minus 1 square. This is by 2. 8 minus 1 minus 1 by 2, 4 minus 1. 7 minus 3 by 2. That is 11 by 2. How much you got? 5.5 cool. 11 by 2, that equal to 5.5 cool. Is it correct, friends? 5.5 cool. Okay. Clear? Simple. Can you try this? The current flowing through the element is I equal to 4 amperes, 40 square amperes. Calculate the charge entering from t equal 0 to t equal to 2 seconds. Then I equal to charge, na? You have to find charge. Q equal to integral I dt. 0 to 2 seconds. Shall I write like this? Integral 0 to 1 I dt. Integral 1 to 2 I dt. 0 to 1, up to 1, 4 amperes. 4 dt. 1 to 2, greater than 1, 40 square. 40 square dt. Integration of constant t, 0 to 1. 4 is common. Integration of t square, t cube by 3. 1 to 2. Substitute the limits. 1 minus 0. 4 by 3. 2 cube minus 1 cube. This is 4 plus 4 by 3 into 7. How much you get? This is 40 by 3 amperes. So 40 by 3 coulombs. 40 by 3 coulombs is nearly equal to 13.33 coulombs. Just remember the formula of Q equal to ITR, Q equal to integral IDT. Then you have to calculate like this. See the one more question. Can anybody answer this? You have to find the charge. This is which curve? Current curve. I told already. Q equal to integral IDT. Area under current curve gives charge. Area under current curve. Just simply find the area. Current curve. Or otherwise you go for integration also. 0 to 6 integration. Not required. Area under current curve gives charge. This is given in microseconds. Sir. T is given in microseconds. Please remember. See this one. Axis you see. Microseconds. 0 to 2. This is rectangle. What is the area of the rectangle? 10 into 2. 2 microseconds. 2 into 10 power minus 6. This is another area. This also rectangle. 2 to 4. This is 7. 7 into 2. This also microseconds. 2 microseconds. This difference is 2 now. This height is 7. 7 into 2. Next, what about this one? This is 5. This is 2. This difference is 2. 5 into 2. This area, and this area squares. 5 into 2, 10 power minus. Can anybody? How much charge you got? Area under the current curve gives the charge. This is 20. This is 14. This is 10. Into 10 power minus 6. The 44 microcoulombs. Is it correct? I got a 44 microcoulombs. Is it correct? In the following characteristics, find the charge. I calculated area. Area of this one is, this is 10, this is 2. Area of this one is, this is 7, this is 2. Area of this one is, this is 5, this is 2. This is 5 and this is the 2. Then total charge we are getting 44 microcoulombs. How to find it? If you are feeling it is a difficult, then better to go like this also. 0 to 2, 2 to 4, 4 to 6. You have to find this integration. That also gives the charge. 0 to 2, 10, 2 to 4, 7, 4 to 6, 5. That only I done here. Clear? Then you find this dt, dt, dt. 2 to 4 is, I am writing this. Like this also you can solve, sir. No problem. 0 to 2, how much? 10 dt. 2 to 4 is how much? 7 dt. Constant now. 4 to 6 is how much? 5 dt. But time is given, it is in microseconds. This is in microseconds. That observation is important. Then integrate and substitute the limits. Then also you can get 44 microcoulombs. Like this also you have to proceed. Go for area under the curve or you can do like this. Next. You try this homework or practice. You find the area and charge acquired by the capacitor after 5 microseconds. This is the current curve. Current curve. You have to find the current curve. What the charge? Now I'm solving. Now tell. Charge equal to integral I dt. charge equal to integral I dt square. Okay, Q equal to, this is one triangle. Area under the current curve. This is the triangle. Half B. B is how much? 3. H is how much? 5. Plus next. This is one area. Clear? Area under the current curve. Otherwise, you go for integration method. Next. See the next area. This is one area. And this is another area. This is a rectangle. Okay, rectangle. Then first this triangle. Half into B into H. B is how much, sir? 3 to 4. 1. H is how much? Height. 3 to 5 students. 3 to 5. 3 to 5 is height is 2. Plus. What about this rectangle area? This is 1. This is 2. This is 3. I'm writing. Rectangle. This height is how much? 3. Correct? 0 to 3 na 3. This breadth is how much? 3 to 4. 1. Here it is asking that charge acquired by the capacitor after 5 microseconds. After 5 microseconds means you calculate up to 5 microseconds. Up to 5 microseconds. Then just after 5 microseconds also same charge. That's why you have to calculate up to 5 microseconds. This is up to 5 microseconds. You have to extend like this. Up to 5. This is one more triangle. Up to 5 microseconds. This and this is the rectangle. Can you tell what is the triangle? Half into this is 3, this is 4. Area 4. This is area 5. Half into B into H. 4 to 5, 1. Na? This is 3 to 4, 1. Half into 1 into 1. Plus. What about this rectangle? This is 4 to 5, 1. This height of this rectangle is how much? 3, 1 into 3. Total is given in micro, sir. I am multiplying with into 10 power minus 6 because of micro. This is how much? 15 by 2. 15 by 2 is 7.5. This is 2 to cancel. 1. This is 3. This is 0.5. This is 3. Can anybody? What is the answer? 7.5 plus 1, 8.5. 8.5 plus 3, 11.5. 11.5 plus 0.5, 12. 12 plus 3, 15. 15 microcoulomb. Option D. You have to calculate up to 5 because the question is asked acquired by the capacitor after 5 microseconds. You calculate up to 5 microseconds. After 5 microseconds also same charge. Just after 5 microseconds. That means you have to calculate up to 5 microseconds. This is the 15 microcoulombs we have. Understand, sir? Or otherwise go for integration method. 0 to 3, 3 to 4, 4 to 5, 5 to 6 like that. So 4 to 5, up to 5 microseconds. I calculated 4. Totally how many areas? 4 areas. 1, 2, 3, 4, 5. Is it clear? This is 15 microcoulombs. This you have to practice. How to practice. This example you have to practice. What are the formulas I given? Using that formulas, you try to solve these questions. This example. This example also you try. This example also you try. These 3 examples that I am giving. These 3 questions I taken from Van Valkenburg. This is the for each chapter there is unsolved questions are there. But whatever the formulas I given, that formulas are enough to practice these questions. Yes, friends, this about the today's session. Today's session that I given some introduction. In the fundamentals of electrical circuits, the first topic that I discussed, what is the charge, what is the current, what is the current density, what is the drift velocity, that is the drift speed, and what is the mobility of electrons, and what is the kinetic energy, what is the power loss, what is the first form of Ohm's law. This I explained. And I solved some questions based on the current and charge. The next session will continue with what is the electric field, what is the potential, what is the potential difference, what is the power, what is the energy. After completing that, then you go for the different types of elements, Ohm's law, all these. Any doubts, friends? Any doubt? Balaji, Kavya, his name, Rajesh, sorry, Rajasri, Abhinaya, another name, Padma Priyam. Any doubts, sir? Thank you. This is about the today's session. See, in electric circuits, you must be very strong in the fundamentals. If you are very strong in fundamentals, how to apply Ohm's law, how to apply voltage division, current division, how to apply nodal analysis, mesh analysis, how to apply source transformation, how to make star to delta, delta to star transformation. If you are very strong in these concepts, then remaining is very easy. Just by seeing the circuit, what type of formula you have to apply? Is it mesh analysis you have to apply, nodal analysis? If you want to get that idea, more practice is required. More practice is required. That's why when you get the more confidence in the electric circuits, if you solve the more questions, if you solve the more number of questions, then only you can get the more confidence. The only way to learn the electric circuit subject is you build up the concept and practice the more number of questions. Once you have to practice the more number of questions, then circuit theory is very easy. If you are not practicing, you don't get any confidence. When you get the more confidence on the electric circuits or network theory, if you solve the more number of questions. Okay. Thank you very much. I'm ending the session.